All right, these are the lesson 4 notes. This is on the states of matter and what's going on with the atoms inside pretty much everything in the universe. So we're going to cover the 3 states of matter that we're going to talk about. There are actually more than 3, but 3 today. Here we start with water. Is this water a solid, a liquid, or a gas at this moment? What do you guys think? You see liquid? What do you guys see? What do you guys see? Solid, liquid, or gas? Solid. This is a solid. Now talk to your neighbor really briefly. What are these atoms doing? Okay. Now don't just say they're moving, because they're locked together, aren't they?
Yeah, but the neutrons surrounding them.
But they're moving, right? Okay. So the atoms inside that piece of ice are still vibrating a little bit. So here's a question. Are the atoms inside the chair you're sitting on moving just a little bit like that? Are they? I'm seeing a lot of head nods. The answer is yes. Even though atoms are a solid, even though something is a solid, those atoms inside of it are still moving a little bit. They're locked together, but just like this is locked together, they can still move. Okay? Now, what happens if we add some heat? I just warmed it up a little bit. Talk to your neighbor. Is this a solid, a liquid, or a gas on the screen right now? Talk to your neighbor. See if you agree. Okay. Is this a solid anymore? Okay. Is this mostly in the bottom of the container? If I took the lid off, would it stay in the bottom? I'm pretty sure most of it would stay in there, wouldn't it? Okay. If I took the lid off, you'd still have it in there. Does that sound like a liquid or a gas to you? This is a liquid. A liquid, all of these materials, all of these atoms are bouncing around, but they are still kind of clumped together. And yes, a few of them are getting kicked off, right? Those are a gas, but most of it's a liquid. This is like a drop of water. If I push my finger into it, does it move, or does my finger kind of slide into it? Right. So, yeah, it's kind of both. If I add more heat, okay, last time, talk to your neighbor. What are these atoms doing now? I'm going to call on someone in 2 seconds. Bobby, what are these atoms doing right now?
They're trying to get out of the box.
They're trying to get out of the box. That's an interesting way to put it. Are they connected at all?
No.
How would you describe their energy level? High energy. They're bouncing all over the place. They have lots of energy. It's a gas. If I took the lid off now, what would happen? Exactly. It would start escaping. So, we have solids, we have liquids, we have gases. Now, solids. The atoms are locked together and they're moving slowly. They have a definite shape and a definite volume. What does definite shape mean? This chair has a definite shape. Has this chair changed shape since I picked it up? No, it has one shape and it stays in that same shape. Okay. What is volume? Volume, you've been using the word for probably for a few years. You know?
Volume is the amount of space that's inside an object.
The amount of space something takes up is its volume. Yes, so it takes up the same amount of space and it has the same shape all the time. Now, one of these is not true for liquids. Briefly, talk to your neighbor. Which one of these is true? Which one of these is not true for liquids? The blues. Does it have a defined shape but does not have a definite volume? Or does it have a definite volume but it does not have a definite shape? Liquids. Talk to your neighbor one more second.
Liquids always change.
So liquids, you're saying liquids have a definite volume, yes, but, and that's right, has no definite shape, but it does have a definite volume. Liquids are atoms that are clumped together. These are they're clumped together, but they're still moving freely. So liquid, atoms are clumped together but moving freely, has no definite shape, but it does have a definite volume. Now I'm adding a nice little picture here. My solids can be in a nice square right in the middle, whereas my liquids all float to the bottom, and gases. All right, so if we remember what our gases look like, the gases, these are going everywhere. And if we took the lid off of this, they would start escaping out the top. They're just going to fill this container up. Gases are atoms that are bouncing around and moving freely. They have a lot of energy, and they have no definite shape, and they have no definite volume at all. And to make our pictures a little bit more clear, I have arrows on these. So I've got little circles with arrows. They're zinging everywhere. So the atoms in this room, are they connected? Are they zinging everywhere, the air in this room?
Yeah, if there's wind, they do more.
They're zinging everywhere. They're not connected. They're gases. Now, temperature and the phases of matter. This is pretty straightforward, okay? If we start with solids, then liquids and gases, which one's going to be the coldest? Shout it out. The coldest, definitely going to be our solids. No.
But different elements have different boiling points.
Right, they have different boiling points, but it's always solid when it's the coldest. And then it's always gases when it's the hottest. So at some low temperatures, some things will become solids. At a medium temperature, it'll become a liquid, and then at a higher temperature, it becomes a gas. And this should seem pretty obvious to you, but as we move this way, we're increasing in temperature. Okay? Now the last thing, these notes. And for years I didn't give these notes because I thought everyone already knew this stuff, and I learned, we have to be explicit about this. These terms, there are terms that go along with changing phases. As we go from solids to liquids and liquids to gases, we change. So, give you a moment to finish copy. Phase change terms. So as we change from liquids to solids, solids to gases, all those things, we have terms that go between them. And here are the terms. We have condensation, freezing, evaporation, melting. And here's this picture that goes along with it. Now, let's just focus on condensation for a second. Okay, so just write condensation just for a moment. If water is condensing, this is one of the harder words that 8th graders come across. What states of matter are involved? If water is condensing on your windshield, if it's condensing on the school bus window, it's going from what to what? From, Dylan?
Water to a gas.
That's, you got it flipped.
Gas to water.
It's from a gas to a liquid. So condensation is when you go from a gas to a liquid. Evaporation, on the other hand, Bobby, is a liquid turning into a gas. So if I'm evaporating something, it's going to end up as a gas. Now, here's a couple that are a little easier. Freezing. Go ahead.
Water, liquid to a solid.
Liquid to solid. And melting then. Daniel.
A solid to a liquid.
A solid to a liquid for melting. Right? Now I'll give you time to catch up, but there's a couple of bonus words here. One you probably already know, one that's going to be a little bit new. The first bonus word, I think it's a hard one. Yeah, sublimation. It's right here. We go from a solid to a gas. Have you guys ever seen dry ice, like steaming, smoking? That's not even turning into a liquid. It is a solid that's going straight into a gas. The other word is frost. What is frost? We're going to have frost on our windows soon. Frost is, Ella?
It's
Yeah, a gas turning into a solid. And this is the end of our notes. So I want you to know the different temperatures associated with each phase. I want you to know these terms and generally what the atoms are doing inside of each phase as it goes from gas to liquid to solid.